Yeah, like, you can go.
Okay. Hello and Vanakkam. My co-host Abhishek and I welcome you all to our first ever virtual web conference, the DevSangamam Day 2, powered by GDG Chennai and WTM Chennai. We are a developer community and we host meetups, workshops and more throughout the year. Before I start, let me ask you one question. How are we doing? I know it's been a couple of months for all of us. Let's remember that we have each other to get through this, and that's all that matters. We had some amazing and inspiring talks yesterday by Sari, Binto, and Soumya. And today we are back with full power packed session for you all. I am super excited. Okay, so Bill Gates once said a breakthrough in machine learning would be worth 10 Microsoft. Computers are computers are able to see, hear, and learn, and this is the phase of ML. So our theme for today is ML and chatbot. The agenda for today includes a talk on how to have a rich conversational actions using Dialogflow by Amanda, demystifying ML for big data by Shivani, and informing human features using deep networks by Akshay. So hereafter, over to you, Abhishek.
Thank you, Joey. That was a great introduction. You precisely summarized what happened yesterday in the day one event. Okay, hello all. My name is Abhishek. As you know, I'm a co-organizer of GTG Chennai, and I'm also a software engineer, mainly working on Python, basically a Python fanboy. So, you know what? Like, I always wonder, and like, I'm always curious to know about. Okay, how do I talk to a machine? I mean, having a conversation with machines are always exciting and interesting. So if you have heard of a term called NLP or so-called natural language processing, basically it's a technology that evolves the ability to turn your text or audio speeches into encoded, structured information based on your appropriate ontology. Forget about that. That was a typical definition of NLP. So in layman terms, it means that NLP will help you or help AI to understand what a human is trying to convey. And the most direct application of NLP in AI is through chatbots. So, hello folks. Let us welcome Amanda, who is WTM ambassador, a community lead of GDG Cloud London, as well as a Google developer expert for Google Assistant. So, over to you, Amanda.
Hello, everyone. Can you see me? Okay. Hello. Hello, everyone. Welcome from London. Hello from London. It's kind of early here, 9:35 in the morning. I know it's already afternoon. You already had your lunch, but let's get my day started with conversational actions. I'd like just to say thank you so much for doing this. I love being part of GDG Chennai. I've interacted with some of the people from the community before, so I'm really excited to talk to you all about conversational experiences. Feel free to talk to me in the chat, and I'll share how to talk to me throughout the talk as well. So the title is Conversational Experiences Using Actions on Google and Dialogflow. Little bit about me. I'm originally from a small city in Brazil. I was born and raised there. But then at some point I moved to London, and it was 5 years ago. And I've been working ever since as a software developer, and I have the community at the bottom of my heart. So as he said, I am a part of the Google programs, the GDG. I'm a Women Tech Makers ambassador. And also I'm a GDE, a Google Developers Expert for the Google Assistant category. So basically, I don't work for Google, but I'm passionate about this technology, and I love to share it with you all. let's start off before we go deep down into chatbots and conversational actions. Let's just start the conversation chilled. I share here photos of 3 movies with you. Probably you've heard about them, you've watched them, but basically what they have in common is that there are machines, that they are interacting with human beings, and after some point they start to get smart. Some of them start to have feelings. Others, they can read things on the internet, they can consume the data, they can become really smart. And at times we get scared of the machines, right? We're like, are they going to get our jobs? What is it going to happen? So I don't know what's going to happen in the future, but from what we've been seeing these days, I don't think they're going to be in a place where a human being can do that job. But definitely many of the jobs that can be automated, that will happen. For instance, I went to a hotel in Vienna, and in there you could self-check in yourself. There were only tablets, and that was very interesting, but there was still one person in there. There were less people working, but there was still one person that could aid people who could not interact with that machine anymore. So talking about that, I don't know about you, but I started using technology with Windows. And for me to achieve something as simple as reaching the control panel, I had to memorize commands. I had to know where to click. But nowadays, if you see kids when they're born and they're interacting with phones, especially smartphones, they don't memorize all these things. They just unlock phones very easily. It's very easy for them. And even other kids and teenagers and other people, they are now getting used of interacting with technology using voice. And how much easier than that can it be? You don't have to memorize anything. And if you don't know how to access something, you can ask for help, because usually, or you should, when you're building a conversational interaction, you should add a help tool. So how can I achieve this? How can I achieve that? So we're no longer memorizing commands, we're using voice. And I don't know about you these days, how it is in your city, but here in London, I'm still on lockdown. And I've started doing everything you can during lockdown. So I've been logging all the food that I eat. And I was thinking about it because I have to always do this very manual thing of going onto the app, clicking many things, clicking to log the food, and then I have to type it. But come on, people have already logged that food before. Everything has already been done many times. So why can't I interact with my phone using voice? Just open the app and log the food using voice. So you can see some use cases here. You can interact with the machine as a user. So about the Google Assistant, we can find it in diverse, I don't know if you've seen some of these devices, maybe you can use it on your phone. Basically is how you interact with your Google account, let's say nowadays, but through voice and many other ways. It could be tapping on the screen. Basically, you're getting things done using voice in a simpler way. So you have an assistant to help you get things done. And it's already available across the globe in 19 languages, 80 countries, and there are more than 1 billion devices being used. So don't feel forced to think, okay, I'd like to use the Google Assistant, but I don't have a fancy phone, I don't have an Android phone. It's available in a number of devices. So I'm pretty sure you have one device in your house that it would work in there. So we can see that every 10 years or so, we see a huge shift in computing from, mainstream mainframe computers to phone to mobile phones. And I have a map here that I can share with you. You can see the adoption of many new technologies at the time and how they're raising. And this is how smart speakers are doing. It's still early days. It's not more than 10 years ago that we hear terms like chatbots and other terms like that, but it's really rising really fast. And I just love, I'm very curious to know about all the things which are to come. I hope you're too, and I'm going to talk to you about some of them. So when you think about the assistant, and I'd like also to hear from you, what have you been doing with the assistant? Do you have just a phone or maybe one of these devices in your house? Is it just laying around? Do you just Google search stuff? What have you been doing with it? So here are some of the things that people have been doing that you can do as well if you haven't yet. So you can listen to music, you can ask for fun questions, basic research, weather forecast, set alarms and reminders, check the news. You can do online search, ask for directions, even if you're at home or if you're driving, if you're in public transportation, sports scores, smart home commands, to check your calendar, your schedule for the day, check the traffic, shopping and ordering items, making calls, playing games, hotel and flight research. I personally hate having to look for the gate to see the information about my flight, so I always check with my assistant. So manage finances, food delivery, playing games, send and receive messages. So here are more ideas of things you've been doing. Have you been doing all of these? Let me know. So, and at the same time, you can do all of them. Maybe when you're in a rush in the morning, or if you're a person like me that don't like doing manual things over and over, you can automate them. When you go in your home app, there is something called the routine, and you can build routines that basically you're going to chain a sequence of commands. So for instance, when I wake up, I like to know about the weather, the news, and the traffic. So I just chain all of these commands to when I say, let's go to work. Okay, G, let's go to work. So you can do that for various things that you do in your life. For me, I gave you an example in the morning, but be creative. See how you can, save time in your day by automating things you're doing over and over. So about the Google Assistant, you tell me, okay, so you're telling me that there are these things called actions and that I can access them. Maybe they're created by someone from Google, by somewhere else, by me, by a friend of mine. So how can you invoke, how can you interact with an action? So let's just understand this first. This is your device. And when I talk to it, basically, it's a conversation between you and Google. So it's as though you're Google searching from a device you own. But when you enter an action, for instance, I created a chatbot Chibi and Katsu Hayabi. So when I enter that action, I'm going to interact with what I created in there. So if you enter chatbot Chibi and you ask about the weather, chatbot Chibi doesn't know about the scope of the Google Assistant. So you'd first have to exit that action to then interact with your Google Assistant again. It's just as though you're on your phone and then you enter an app. You can't really do something in a different app, so you have to exit. And one thing that all of them have in common is that you have to say their full name to get started. For instance, if you see, for you to talk to chatbot Chibi, you have to say, okay, G, and then there are 3 sentences that me as a developer, I wrote them as invocation sentences that you can then start my app. So just imagine there is a pool full of different actions, and for you to start them, you have to say the exact name. And nowadays, you can also leverage voice interface in your apps, and you don't have to have the ultimate, biggest, better smartphone there is in the market. There are people in countries like India and in Brazil that cannot afford a good phone, and it's a reality, and many people would still like to interact with voice. So when you're interacting, when you as a developer, when you're creating something, you have to have these folks in mind. So the way that they are going to interact with technology can be different than the background you had. So you have to think that, so I have to create something that maybe the screen is not there. It's just for voice, just like this little device here. So you have to have in mind what is available in each machine for you to talk to your user the best way possible, to talk in their language, to talk in their own terms. And I don't know if there are content creators here, but basically, if you're not a dev person, you can still create things in which you can show your content in a better way. Let me give you one example. This is one application that my friend in Brazil made. So basically, she created a video on YouTube, which was a tutorial. So you can see here that I'm going to type, first of all, I'm going to just put the display because this one contains a display. And you can see step number 1, I'd like to go to the next one. So I write or say with voice, next. You can see it goes to step number 2. Go to the next one again. It goes to the 3rd, and then the video jumps to there, or previous step, last step. So now you can consume tutorials on the internet without having to, find that correct timestamp. So how can we achieve that? I'm not sure if you ever used the Google spreadsheet, but basically there is a template, how-to video template, which can be shared with you. And then basically what you have to write is the title, the step number, the title, the timestamp, from which timestamp to which timestamp that one step is about, and then bullet points. So even if you're cooking, if at some point you can't use your hands, or if you can't use your hands at all, you can now interact with more content, which is curated for you that way. I think this is just amazing and very welcoming for folks who also don't know how to code. So it's a very, very good entry point for you to start building actions and other types of apps. Another use case is on how I use it. This is my website, and I put a chatbot in there. Basically, I created it with Dialogflow, which is a natural language understanding tool, and then I integrated it with a different tool because at the time when I created it, there wasn't a tool that I'm going to show in the next slide. And then it's very easy for me because I automated most of the questions that people were asking me over and over. And then my bot just handles everything for me. And in case it doesn't know how to handle one of the queries that you're talking to me, it's going to then escalate to me, and then I can take over and answer it. On the note of the other app that I didn't know about, there is this new Dialogflow messenger, which is still in beta, that basically you can just add this rich talking there. You can add it to your website, may it be localhost, may it be even production. So basically the conversation that you're creating can now be available for you to talk without you having to worry about the UI, how I'm going to put the chatbot in there. So that's already handled for you. Another thing that you can do, I was thinking about that. You know that, I don't know about you, but this is my mother-in-law, and she has a recipe book. And then what happens if something happens to that book? Like, there's many recipes there, which I want them to carry on to the generations. So bring it to the Google Assistant, write it down, maybe with the example that I told you with the video, or maybe you would like to write it with images and text, with voice. So not even that one example, which is very custom, but if there are recipes on the internet, you can also see them on your phone or on your device that has a screen or voice. So you can now start interacting with data in a more natural and human way. And another, I don't know if you know the person in the picture, that's John Skeet. And about, 1-2 years ago, we created this action together. Basically, we wanted to create something for for folks who'd like to learn how to code. And then you could find people based on the piece of technology they're interested in, where they are in the world, and also their contact. And then basically what we did is we created this both in Node and in C#, and you would interact with it with voice. But if the person started to saying something with a negative connotation, we use sentiment analysis to see when the score was starting to get a bit negative. And then when that happens, we would then escalate the conversation to a real person. Of course, that was just a demo. And in real life, we just called each other because we put each other's numbers that we purchased on Skype back then. But think of the possibilities. I don't know if you ever try to, cancel a bill, and then you start to get mad, you're angry, and then someone says, okay, we're going to put you in contact with our manager or someone else. But until you get to that point, you might get your user really mad. You might even lose that user. They don't want to consume your service. So why not use the power of sentiment analysis to know before the user even gets that mad, to know when to escalate that call to a real person. And another thing that you can do is you can create projects and you can get people to help you out. For instance, I have this open source project called CloudRobe that it's still early days, but if you'd like to get involved, basically what I'm doing is I'm using React and Firebase, and I created both a web app and also a conversational action that you can take a picture of all the clothes you have in your wardrobe, and then it suggests to you, you can, consume from a weather API that gets where you are, and then you say, what can I wear today? And then because it already knows the weather of where you are and you're constantly training it, it's going to know which clothes to suggest to you. But again, this is me creating it, and maybe you can have a similar idea. You can create something similar, or you can think, no, that's lame, I have a better idea. So just go ahead and create things. There's a platform for you and people to share it with. And again, talking about screen capabilities, you might think, okay, you told me earlier that I have to know if there's no screening here. How am I going to create this? So basically, I don't know about you, but I'm a front-end developer. And I have to worry about breakpoints and how it's going to work on each screen and everything. But basically, the way that you build for the Google Assistant is if there is voice, it's going to work on a platform with voice. If there is screen, your content is only going to be available on the screen. You don't have to worry about that. Google takes care of that for you. However, if you as a developer, when you're building it, you don't take that into consideration. You're always thinking that your users have screens. Your user might not interact with your content the best way possible. So don't worry about how it's going to be shown in there. It's going to be shown, it's going to be responsive. It's going to be shown in the correct platform, but you have to have your interactions and you have to build the flow correctly on how the user is going to interact with it. And also you can bring brand awareness. This is an example of an app that I created, and I wanted to portray that the martial arts that I practice, Aikido, is for everyone. And then there is a place in the Google Assistant simulator, in the actions on Google Simulator, that you can add your brand awareness. So I think it's very important for when you're trying to convey the persona of your action, and talk to your users in a way that you really show your brand. And again, I'm talking a lot about being a developer and developing things, but if you don't know code, or if you just would like to get started and get something done quickly, you can also use these Google spreadsheet questions and answers. So that's how basically I created this game. I added the questions, the hints, and the answers, and then people can interact with this Aikido game. So a bot that does one thing well is better than one that does many things poorly. And I don't know if in your business or in your community or in your house you'd like to create something, and I'm sure there's many things you'd like it to do, but what I would recommend is that you get it to do one thing very well, and then you start to work on more things, because when you start to do many things at once, it doesn't usually turn out well, or maybe you're not going to have enough budget to work on that project and it can be left aside. So, iterate on things, build it, see it working, talk to your team, may your team be a work team, a house team, but get things working step by step, get that feeling of I got this to work. talk to the community, learn more, see what is available for you out there. So I'm going to show you how a life of a conversation is in a nutshell. So this is an example of an action I created with the Telegram integration. So the conversation is initiated. If you use Telegram, you know that when you find a bot and you click it, there is a command which is /start. But if you're coming from the Google Assistant, maybe it's just going to be OKG talk to wedding chatbot in this case. So however way you're starting, you have a welcoming intent. So this is how it is shown on the Dialogflow platform. When the conversation is initiated, you go to the welcome intent. And I have some training phrases here in Brazilian Portuguese, and then it could be hi, hello, hey. There are ways that people can say, or it can also be triggered by an event. So it matches the default welcome intent when the user talked to it. Then what happens is a response has to be sent back to the user. So there is a part which says text response. Then that response is sent back to the user and the user gets it. And then that goes on and on in loops, but not always to the welcome intent. Whatever it is that you're saying is going to be matched to a different intent, to an intention. It could be, do you think it's going to rain today? So you could have a rain intent. So at times, things can get confusing when your intents are very similar. So that's why it's important to use context and other ways to control the flow of the conversation. So this is an actual app that I used on my wedding. People were asking questions over and over, and then I just said, no, talk to my bot. And I started to get I started to get my guests to actually train it. So the more questions they would ask, the more intents I would create out of it. And it's brilliant. If you need it, just let me know and I can share it with you. Another very powerful thing are the integrations. So I've talked to you about integrations before. I talked to you about the second one, Dialogflow Messenger. So the idea is you don't have to create the same thing over and over. Okay, I just created this brilliant bot for Facebook Messenger. Now I'd like to create one for Twitter or for, I don't know, Telegram. So the idea is you build it once, and then for each platform, you can show how you would like your content to be seen, or also see the limitations. For instance, on Facebook Messenger, there is a number of quick buttons, quick replies that you can use, but then other platforms don't have quick replies. So you can, at the same time, choose how you would like it to be seen, but also respecting the limitations of each platform, of each channel. And these integrations make it very easy for you. So let's talk in a very quick way, an overview of the things that you need to know to build a conversational action on Dialogflow. So on intent, as I said before, you have to know the training phrases, the actions and parameters, and the responses. So basically everything that you say in your sentence can be extracted and it can be matched. And then if I'm talking about location, that can be an entity location. And what is an entity? It is they are the noun. So basically, if I say S, we're talking about t-shirts. It can be for S, small, tiny, little. So basically, you can talk about the entities of the words you're talking about. And some of them are already out of the box for you on Dialogflow. So when you're talking about address, measures, there's a handful of them. You don't have to train them. But for instance, well, quick cultural note. In Brazil, when it's a wedding, it's common, not all the weddings, but it's something which is not uncommon. We give flip-flops to people so that they can dance, getting off of their heels, the women. And then I don't think this is a thing which is used by many people worldwide. So I can create a custom entity in which I call it flip-flop. And then when people talk about flip-flop, they're going to be taken to that intent. And then I can extract that entity and do what's best for me in that interaction. And there's also composite entities. For instance, I want you to tell me your full name. And then I have first name, middle name, last name. So I can use different entities in a row, and then I'm only going to move on to the next part of the conversation if I get all of these parts. Contexts, as I said before, it's the way that you can control the flow of the conversation. You can carry on messages to the following, you can carry on information to the following messages. And you can also set a lifespan. So when I say something in the lines of, what's the weather like in London? What can I do in there? What's up in there today? So you can set the lifespan that after 3 or 4 conversations back and forth, that there it is not going to work anymore. So this is very, very powerful. I think this is one of the best resources that we have in this tool for you to build bots. There are fulfillment, which basically you can answer the questions in a hard-coded way, but you can also fetch the answers from endpoints. So that's also very, very important, how you can connect it to a webhook, to a backend, which is maybe hosted somewhere else. This is one example on how you can use a webhook on the Dialogflow tool using the Firebase Facebook, using the Firebase tool. Basically, if you know Node, you can do it even on the web app. But if you'd like to use other languages, other programming languages, that's available as well. And another very interesting thing is re-engaging with your users. So there are tools, for instance, like push notifications or routine suggestions and action links there. So there is a link over there that you can check for yourself, things that you can do to get users to, be engaged with your action. And it's really, really important because nowadays, with the number of tools and apps and actions which are available out there, what are you using to get the users to be engaged with yours? Why should they even see your content? As I said, it doesn't have to be just in one platform. You can make it available in video, in web apps, on Android applications. There is a handful of ways that you can speak to your user. So make sure you're out there in all the platforms that you can and re-engaging with your users. But I'd also say in a good way, because I personally don't like getting push notifications out of nowhere for nothing. So know when it's best. So some documentation and resources for you to get started or maybe get to the next level with your Google Assistant and Dialogflow knowledge. And if you'd like to talk to me, don't send me an email. Talk to my bot on my page, www.amanda.ml. And I'm more than happy to help you out. Thank you very, very much for this opportunity, and I'm available to take some questions.
So that was really a good, insightful session, and I really liked the kind of projects that you have created. They are so fascinating. So I was like curious, why didn't I think of that, making a bot for doing this thing or that thing? But I'm pretty sure like you have given a lot of project ideas to people who are watching this video, and definitely they're gonna use this. So I guess
I would say you don't have to create the app that's going to solve the problem of the generation. Start by solving your own problems. May it be like you have a plant, you don't know who watered the plant on the day, so just a chatbot to who watered the plant.
We also have few folks in our team itself. They have created a bot, chatbots to just track where their food order is. So once it arrives, then it will notify, hey, your food is arrived. So yeah, we are open for questions. So we'll just go one by one.
Okay.
Okay. 1 second, Arvind, can you put these questions on screen?
how well can chatbots adapt to non-English or incorrect English acronyms that we use in our day-to-day texting? For example, you, GTG, to go, etc. It depends on which chatbot you're using, which natural language understand you're using. In terms of dialogue flow, it has been overly trained in the English language, but I build many bots in Portuguese, which is my native language, and many of them, they're not really good. They don't have enough trained models and data. So that's when you can use the custom entities and you can create them yourself. So even if it's not there, you can create it for your own action.
I hope that answers your question, Shyam.
If we all have smartphones, why do we need smart speakers? I mean, why to spend extra on hardware? You definitely don't need it. You don't need it. Many things you can achieve from your phone, that's correct. But for instance, I find them very handy because nowadays I don't live in my home country anymore, and I just talk to my family very often. And I have a Google Home that my camera, it moves for me, so I don't have to be there, correcting where the position where the camera is. I just, I'm talking to them, then I go and wash the dishes, and it's still following me. Or at times when I'm cooking and I can't, touch something because at the time my hands are dirty with cooking, I can just use voice and I can interact with that. As of now, I don't think for many people it's something that you need. For some people, maybe there are some use cases, maybe people with impairments that can be very, very handy for them. But I personally, that's my opinion, I don't think it's a must-have thing. If you have it on your phone and can help you in a way, I think that's enough. But that's up to any person to have that opinion.
Okay. So I guess we have one more question from the same person. Is talking about what is the difference between TensorFlow and Dialogflow.
Oh, there are different tools. You have to talk to the TensorFlow experts. That's not my area of expertise. But in terms of Dialogflow, it helps you build conversational actions in a way that you as a developer, you don't have to deal with some of the hassles, which are so hard to build for voice nowadays. So as someone was asking before, how can I deal with these things that people are saying, GTG, or how am I going to get different accents or different things? And in terms of TensorFlow, you got to ask someone else.
Okay, fine. So we have one more question from Somasundaram. So he's saying
Sure.
how to deal.
By the way, thank you very much for all the questions. How to deal with limitations on actions on Google? I cannot add more than 10K entities on actions on Google, whereas it works on Telegram and Dialogflow. Hang on. How to deal with limitations. Okay, so yeah, each platform, there are their limitations. I personally didn't know about that 10K entities. I think you're a heavy user. Well done. What I do know is that there is a Dialogflow Enterprise version of Dialogflow. I'm not sure if I said the name correctly, but there is one paid version. I'm not sure if it would raise the number of entities, but definitely there are a number of things which can be raised in a paid tool. But I'm not sure about that one specific thing for actions on Google, if that would be available. Sorry, I don't know how to help you with your question, but definitely talk to the community. There are different places we are on Reddit, on Twitter. So whichever question you have, also on Stack Overflow, ask it. And if one expert can't answer, someone else will be there to help you out.
Sure, I hope so. At least that helps you. So Amanda, we got few questions for you. I mean, from our end, kind of, rapid fire questions. Okay. So let me start with that.
Mm-hmm.
So what's your favorite Google action?
My favorite Google action?
Yeah, among the, the one you stated along, you have a lot of, but what's your favorite one?
Wow. Should have prepared me for those before. I use many of the ones which were actually created by Google, so ways that I can interact with my own Google products. Favorite action by other people. So I currently I've been helping many people to get started, and I go through many of the basic ones. I don't think I actually use on a consistent basis actions which were created by other people. I mostly use it to interact with content, for instance, the recipes and other things. But if I have to answer your questions, it's the ones which were created by Google that I can interact with my calendar, for instance.
Okay. So by the way, for the folks who are asking questions about GDE, like how to become a GDE, we will go to that question later. I mean, like we have a few more questions for her, and after that, we're gonna ask the same question. So just have a patience. We will have a deep insight on that. So Amanda, the next question for you: if you have to build a Google action, like if you have published all these actions, so like is there a place where they can find all these actions?
Yeah, there is the directory. It's the first link in here below, the Google Assistant directory. So there is, when you build it, it's going to be in test mode. Then you have to go in a series of things that you have to do for it to be published and to be seen to other people. So let's say you finished to create something, you can send your test link for other folks to interact with it. But if you want it to be available in the platform for everyone, it's going to go to that first link over there.
So if you all are like really want to access those actions, so the link which is mentioned here, Bitly links, you can actually go there and you'll find all those actions. So coming to our next question, like this question was already asked by one person, why I need a speaker if I have a phone. But we would like to know which is your favorite place to use Google Assistant. It's a phone or a Google Home device?
I think there are different use cases. When I'm now, well, during quarantine that I'm at home all the time, I do use the speaker a lot more because mine can recognize my face. So I just go in front of it and then it tells me what's on my calendar. And then I've set many things, like instead of saying call the name of my dad, I just say call my dad. It's very handy. But on a day-to-day basis, because this one is in the living room, I use my phone a lot more because it's always with me. So I think it depends on the time of your life and where you are.
Yeah, that's true. So I see like you have automated a lot of your daily activities with those actions. So there is no actually your favorite one. Maybe it depends on where are you and then you're going to use that. So it can be a speaker and phone as well. Yeah, that makes sense. So coming to the next question, like a lot of people are asking, how can someone become a GDE in Google Assistant, and what are the different skills and qualities are required to qualify for that?
There are different categories that you can become a GDE, which stands for Google Developers Expert for. And I have some links, some resources that I can share with you. You can share with them as well. But basically what you need to do is be passionate about that piece of technology. It's not only about being like, oh, I really want to be an expert for cloud. But it's not something you really like and something you're going to keep doing. So in a way, it can become a sad thing, even if you do become a cloud GDE. So first of all, find one piece of technology that you like. You don't have to be an expert in it. You don't have to be the best, but be passionate. Start writing blog posts or share on any platform that you like, may it be video, Twitter, anything. Just start sharing with the community. And if you know one little thing, you're better than what you were yesterday. So just start to interact with the community. That's what it's all about, to being able and liking to share your resources with the community. So both learning from them and teaching them. So that's thing number one, the passion for community. And the second thing is, if you're going to keep on studying that and interacting with that, and you're going to know the caveats, what is good, what is bad about that piece of technology, most likely you can help the team that's actually working on that platform. So once you have, that pipeline of things that you've built, talks that you've given, and again, you don't have to be an expert to give a talk. Start with 5 minutes, 15 minutes. Talk to GDG here. Tell them you'd like to just show off a project you've been building. And then, you know what? After quite not that much time, you're going to have that beautiful portfolio and you're going to be inserted in the community, and it's going to be easy because other GDEs are even going to be eager to share about what you're doing. So it is a beautiful program. I love to be part of it, and it is for everyone. If you have passion about something and you invest the time in it, I'm sure you can get there.
So I hope Ismail and other folks who asked the question, like this helps a lot. So you need a passion, and of course the passion, then you'll create a lot of projects and then have, that sort of feeling to share the same knowledge with others. So we also got one interesting question in a comment, and I really want to know this question as well. So it's from Bhavani, and she's asking, like, tell us about how you become your GD. Like, how was the journey?
Okay, I'll try to sum it up. It was a lot of back and forth, but basically, I've always liked the Google Assistant. When I arrived in London, I'm being a woman in tech. I don't know if some of you share the knowledge. I started to go to meetups and I wanted to help out. I was there always helping out. And when there is the networking time, the one thing I'd always talk about is chatbots. You know what? You'd start a conversation with me, I'd be talking about it. Then I became a GDG organizer, and I would just take names. I would never go on stage, ever. And then I'd be even afraid to take names because there are so many nationalities here in London. I'd be afraid to, take someone's name wrong.
Yeah.
But then with time, I started to, interact more with the community, and people are like, you seem to like this chatbot gig. You should give a talk. I'm like, no, I don't have anything to share with anyone. And then I gave a talk to this GDG that I'm currently a lead of. And people are like, well, this is really cool. It was like the most basic talk you can think ever. But people appreciate it and they actually learned something from me. And then after that, I didn't stop. I had that one talk and I gave it over and over to tons of people. And then I was very curious reading about things online. And then there was this developer advocate. And then I just pinged them an email. Like, I didn't even know them. I said, hey, I've given like many talks and I've written all these blog posts. Do you think that maybe in a couple of years I could possibly become a GDE or something? And he was like, this is amazing. I think you're ready. I'm like, no. I'm not ready at all. No, I just for the future. Like I had zero confidence in myself. And then I went to a conference in America, and I had many people from the community, GDEs, and they're like, I think you should be a GDE. So I wrote everything that you have to write in the platform on why you want to do it, but I didn't have the courage to send it. So my friend Daniela, she pushed the button for me. And then I had, of course, the technical interview, the community interview, and I managed to pass. So I guess other experts thought that I was as passionate and knowledgeable as well. But don't get me wrong, I didn't think I was ready at all. But at some point, because the more you learn, the more you think you don't know things, because there's a lot more to learn. And that's the thing. As you can see, some of the questions here, I didn't know how to answer. Again, I don't work for Google, but I have a passion. And every time you ask me these questions, I'm going to study and learn more, and I'm going to share it with the community. So don't think on where you are today. Think on where you want to go. Ask for help for the community and other GDEs.
Yeah. Okay. That was a great journey, because I feel the part of community is also very important, because once you start your journey, I mean, like you were not sure how do I get started with it, but yeah, community encouraged you, and then you pushed yourself, and then you became a GD. So yeah, folks who are in the audience, you can actually be a part of community. Try, if you think you are really a good person in that particular domain, try to share your knowledge, and definitely someone in the community will encourage you to do so. So
Definitely.
Amanda, thank you so much for coming here. Like, it's our pleasure to host you. Thanks a lot. We'll see you soon.
The pleasure is all mine. Have a good day.
Yeah, you too. Okay, folks. So I hope that session helped you a lot, and literally it was so amazing. Like, seeing those projects were so cool. Now, guess what? So we have a next speaker available here, but before that, I would like to start with, like, everyone is saying data is the new oil in the IT industry, and we have seen phenomenal examples of that. How big tech firms are using them, to get their products up to the market. And like, so our basically next session gonna be on that topic. So our speaker gonna take us through how to use this ML on top of big data. So let's welcome our next speaker, Shivani Chandar. She's an incoming software developer at Microsoft. She has been awarded with a lot of scholarships like Grace Hopper, and she's also a WTM scholar and has been an intern at Microsoft. So let's welcome Shivani. Over to you, Shivani.
Thank you so much, Abhishek, for that introduction, and thank you for having me here. I'm really happy to see all of you this afternoon, Sunday afternoon at DevSangamam, and I really thank GDG and WTM Chennai for organizing this. I'm Shivani, and I am almost completing my undergrad in CS at NIT Trichy, and I'm a WTM scholar, like Abhishek mentioned. I'm very happy to be a part of this wonderfully diverse set of speakers. Can you see my screen? All right. So today we will be talking about machine learning with respect to big data. I will first start off with clarifying a few concepts around machine learning and big data, and then we will move on to actually seeing what's so special about big data and how specially machine learning algorithms will have to be done in a big data context. All right. So there are a lot of terms that you see when you come into this domain. There's machine learning, deep learning, artificial intelligence, and so on and so forth, right? So first, let me start off with what machine learning means. So machine learning is nothing but a set of algorithms which are applied on data to understand the pattern in the data and then to fit that data into models. So you have a lot of novel algorithms that are used for this purpose. And I'm not going to go deep into all those wonderful algorithms there, which is a course by itself. But I will be starting by just two very basic concepts of ML, which I think you should know before we move on to later going into one particular ML algorithm, which I'll be taking to break down and explain in the big data context. I will be very happy to take any questions you have at the end of this session. So machine learning problems are of two types. One is called the classification problem, and the other is a regression problem. So let's suppose you have a problem that says, I have a lot of images of dogs and cats, and I want to say, when I get a new image, is this the image of a dog or a cat? Then that's a very straightforward classification algorithm, because you're going to classify as to what type this image belongs to. Now, consider you have a kind of data where you have the features of a laptop, say the specs like RAM, storage, the weight of the laptop, and then you have a column that's called the price of the laptop. And if your task was to predict the price of the laptop, then that is a regression problem. So there are going to be different kinds of algorithms for classification and regression. In fact, so this example I gave you for regression, you can also convert it into a classification problem. If I were to say that all laptops below the price of 50,000 are called low-end laptops, and all laptops above 50,000 are called high-end laptops, then for the same features, I now have my output as just low-end or high-end laptops. And if my task, when I get a new set of features of the specs of the laptop, is to classify if it's a low-end laptop or high-end laptop, then that is just converting this regression problem into a classification problem. There is another concept called supervised learning, wherein you're given the label of every data point. So I give you all the features of a particular laptop, and I also give the label along with it to say that this is a low-end laptop and this is a high-end laptop, and like that I do for every point. So you know what point you're seeing, what is the label of that point, and you learn and you do your algorithm in such a way that you're always cognizant of what class it belongs to. There's another set of algorithms called unsupervised learning. For instance, in the same example, let's say this entire column of what label it belonged to, what kind of laptop it was not there. Then your algorithm will try to find some patterns. Let's say, okay, all the laptops with low RAM and low storage are kind of occurring together. The ones with higher RAM are usually having a higher storage. And so you will be able to see two groups of data in your entire data set itself. So you yourself will be able to see that few are similar to each other and they're distinct from this other group, except you won't know what to call them because you weren't provided with the labels, but you were able to differentiate and understand that there are two kinds of things in the data given to you. So that is an example of unsupervised learning. There's also many other kinds of learning like reinforcement learning, which I would definitely advise you all to go read about if you haven't yet. So this Venn diagram that you see here is a very popular representation of the whole terms of artificial intelligence, data science, and machine learning. So this is popularly used to clear all the confusion. So I said machine learning is a set of algorithms, right? There is a particularly interesting subset of machine learning algorithms called deep learning. Now, these have an architecture called the neural network, which is based on how the human brain works. So there are layers of neurons in your brain, and this set of algorithms are inspired by that and have many layers of neurons, which makes it to be called a deep neural network and hence deep learning. So deep learning is essentially a subset of all the algorithms that are available to perform machine learning. So next, there's this larger superset of artificial intelligence. So artificial intelligence is nothing but when a machine is going to perform something that typically only humans used to perform, like classifying an image to its particular category, or all that Amanda talked about, having conversations, chatbots. Now, all that comes under artificial intelligence. Yes, machine learning is extremely useful for machines to be intelligent and possess artificial intelligence, but that's not the only thing which is a part of AI. You also have, so let's say there was a domain expert who knew in and out about a domain and was able to say, if this happens, then this will happen. If something else happens, then this event will occur. And if they were able to translate it into a proper set of rules, and they're able to translate it into a proper set of rules and then have a rule-based system, then that is also artificial intelligence, right? So there are many other interfacing and things also that contribute to artificial intelligence. The next thing that is there is data. So in all the machine learning algorithms that I talked about, we said that we will be modeling over data. So the entire task of not just building models over data, but also pre-processing it, cleaning it, and just visualizing it or performing queries on data in itself is a huge task and not necessarily used for ML or AI. So today, we'll be seeing one particularly important thing in data science, which is big data. So as Abhishek mentioned, data is the new oil. And so if you see this Forbes report, in 2019, in every minute, so much of data has been created. Over 500,000 tweets have been sent every minute. Over 18,000 texts are sent every minute. Over 4.5 users are watching YouTube videos. So much of data is being created and generated and consumed every minute. Now, this is why today big data is very important. But that doesn't mean that we can directly get to work with big data. You can't think of it like any other normal data application and apply your algorithms and tools on it, because it has very special properties to itself. So these are popularly called the 5 V's of big data. First is the sheer volume of data that is there, which makes it big. The next is the velocity at which data is coming. Take, for instance, the tweets of DevSangamam that GDG Chennai and all of us have been putting on Twitter. In just the last couple of days, I'm sure so many tweets have been coming in. and more are to come. So if I were to leverage this data and do a sentiment analysis on Twitter of what people are thinking about DevSangamam, then I need to be cognizant of the speed at which, the velocity at which data is coming when I'm working with such big data. The next is variety. So today you have Instagram posts, Facebook posts, which are not just text, but you have links, you have hashtags, you have photographs, videos, and so on and so forth. So there's a lot of variety also coming today with the data. And all these also bring with it veracity, which means that there's a lot of errors and inconsistencies and lack of formatting and many things which you might have to hover around and work with your data. So big data has all these properties, and when you're able to leverage this amount of data and this variety of data and take care of all these V's, then you achieve value. You're able to draw insights and you're able to use this big data and create a value out of it. So clearly these show that when you're using big data, you can't use it just like you use any other normal data which is not big. And so you need specific architecture and specific tools and a specific way of writing algorithms if you want to do it on big data. And that is, okay, we'll come to that in a while. Before that, let me tell you a little story, which I hope you will take as an analogy to what I'm going to tell later about the whole architecture and programming model for big data. So not so long ago, traders used to use horses to pull carts to trade their goods. Everything was going fine and trade was flourishing, but let's say the trader wanted to give more goods one particular day. He realized that there was more load he wanted to put, and the horse found it difficult to take so much of good. So what it did, it tried, but it couldn't move the cart, and the trader didn't know what to do. So let's say the trader gave it more strength boosters and anything which it thought could make the horse bigger and more powerful to pull the cart. It worked slightly. A slightly higher load was able to be pulled by the horse, but when the load increased further, it just wasn't able to. There's this level of saturation, right? Only so much can be done by a single animal. So then, let's say another trader was able to identify what to do, and he gave this very intuitive thing, which we feel now, that he made two horses to pull the same cart, and now it was easily able to pull the significantly higher load of which was there in the cart, and it was able to do its task, and so the solution was achieved. So I want to draw a parallel between this and our computing resources right now in big data. So the horse is something like your storage and compute. There's only so much you can store in a single disk. There's only so much compute a processor can give you. But the rate at which your data is exploding today is much higher than the rate at which we're researching and finding disks and processors and increasing their capacity. So what this means is we should be able to intelligently come up with an architecture, come up with a model such that we can arrange multiple disks and processors together so that we can be able to work on that humongous amount of data. So what helps, the architecture that helps in all of this is called distributed computing. So before I go on to explaining about distributed computing, it forms the basic of many frameworks of big data. And today I will be talking about two very popular big data frameworks, which are Hadoop and Spark. So Hadoop and Spark are two popular big data frameworks, and these are based on the distributed computing concept. So Hadoop is open source framework. And so what is the meaning of distributed computing? So distributed computing is nothing but you have many computers, and all of these are autonomous in their own way, in that they have their own I/O, processor, memory, and all of that. And they are distributed in different places, and they are connected through a network through which they can pass messages and communicate. So this is what is distributed computing. Now, you should be clear that distributed computing is different from parallel computing. In parallel computing, you have a set of processors which are working in parallel, yes, but they usually have a shared memory, and they're not autonomous computers in themselves connected over a network. They're just a set of processors, probably within the same computer, which are conversing over a shared memory. So along with distributed computing, what you need to know is about a distributed file system. So we all know what a file system means. It's just the way your files are organized and retrieved in any operating system, right? So Linux has a file system, which is a root, and then you have a tree structure under it, and then there's a Windows file system. So in a distributed environment where you have different computers and different computers talking among themselves, you need to have a specific file system for that as well. And that is called the distributed file system. So Hadoop has two components. One is the Hadoop distributed file system, which takes care of organizing the files and the way you're going to access it and retrieve it. And second is the Hadoop MapReduce model. Now, this is a very important part of today's presentation, and I will be elaborating on what MapReduce is later in my talk. So Hadoop distributed file system is going to give you the basic architecture, and on top of that, MapReduce will give you the algorithmic paradigm, which helps you leverage this file system and this distributed architecture. So we saw about Hadoop. Next, we're going to see about Spark. So Spark is, again, another cluster computing technology, which is, again, like a distributed computing technology, but with groups of computers as one. The main difference between Spark and Hadoop is that Spark has in-memory cluster computing. Now, what in-memory means is the computation, when it's being performed, the data is present in the RAM. And we all know that when this happens, a higher speed is achieved, right? So because let's say in Hadoop, where all the data needs to be taken from the disk every time you need to process it, that's going to give you a lot of latency, unlike in Spark, where everything is done in memory. So it's much faster because all your data is already available on the RAM. So it's very useful for applications where you do batch processing, like you can take a batch of data from the RAM and bring it to your RAM, do all the processing, get the next batch, and that really increases the speed because of in-memory computing. So it's very useful in streaming workloads. Whenever we say streaming, I think the first requirement that comes to our mind is speed. And because Spark is one of the fastest out there, Spark is used for streaming workloads. Netflix, Spotify are a few applications that use Spark for its big data. So these are the components of Spark. You have a machine learning library, a streaming library, a SQL, and graphics. So I will be focusing on this machine learning library for the conversation now. So for all of you who have worked with, let's say, scikit-learn, you know that it has its own machine learning functions. And then you have Spark, which also has a machine learning library with machine learning functions. So scikit-learn has a function to perform, let's say, a machine learning algorithm A, and Spark's ML library also has an algorithm to perform the same machine learning algorithm. So what is the difference between these two is what is crucial, because Spark functions on a distributed environment, but your regular machine learning algorithm is not going to function in a distributed environment. So there is an inherent difference in the way these need to be written, and that is what we are going to see now. What facilitates this is this programming model called MapReduce. So MapReduce is nothing but, simply put, it's just two phases. There's a map phase and a reduce phase. Now, it's a programming model because you can convert any existing nice algorithm that you have to somehow follow this model of having a map phase and a reduce phase, and then being able to do all these mapping and reducing in parallel. So you need to be able to write your map functions and reduce functions so intelligently that they should be able to be done in parallel, because that is the crux of distributed computing. You're going to perform all these separately in different computers, right? So let's see more about MapReduce. So let's take an example and see this. There's a very popular example of word count, which is usually taken when you're talking about MapReduce. So let's say your input is a file with many sentences, and your task is to find how many times each word occurs in that file. So let's say serially, how would we go about this? We see every word, and then we have a dictionary of counts, and we have the word and the corresponding count, and as we see every word, we see through our dictionary and update the count. Great. But of course, we're now talking in a distributed environment, which means this data has been sharded and sent as different paths to different computers. So in each of the computers, we will have to perform this word count algorithm as the map phase, and then you will take the results. You'll have small dictionaries in each of those computers, and you take these results and you have to reduce them to get your one final output. So if you didn't follow that, let's take an example now. Let's say I have these 3 sentences. Welcome to DevSangamam by GDG Chennai. GDG is a great community. Join GDG Chennai. So you can see on your left that you have the input. Welcome to DevSangamam by GD, and all those words together. So assume I'm going to shard this as 3 words per block and give to different blocks. Here our different blocks are imagined as different computers, which have their own processor, memory, and everything. And all of these are, of course, connected through a distributed network. So you have 3 words each in each of the blocks, and then you have a map step. So what's happening in this map step after you've split your inputs is that in each block, the word count algorithm takes place. So in map, you're doing nothing but performing that normal naive word count algorithm, but inside each computer parallelly. So if you notice the arrows, it's going from one block to another on its own, and all this is happening parallelly, right? All right. So great, we've mapped it, and we have in each of the blocks of the computer what is the count of each word that you have. Then we do a shuffling. That is, we accumulate all the data we got from mapping in each of these computers, and this is where them being connected through a network comes into play. And we shuffle and we consolidate the data to club things that make sense together as one unit. And after this, we do a reducing. So reducing is nothing but if we have a GDG count of 1 from 3 different inputs, then the shuffling would have just clubbed them together and kept it. In the reduce phase, what we would do is add up all those counts and have it as the count of GDG is 3. So in this way, after reducing, we would have gotten the count of each and every word in that file, which we split into different blocks, and we will get the final output, which we wanted as our target. Great. So there's a lot of advantages to MapReduce. I think the crucial thing you need to notice is these parallel lines going from input splits to mapper and to the reducer. These parallel lines where you're able to perform everything in parallel in the different constituent computers is what is going to give the great advantage of saving time, which is crucial when you're working with a lot of data. So parallel processing by doing this divide and conquer sort is what is going to offer you this advantage. And the second and really smart thing, which is my favorite, is called data locality. So typically when you have a function that performs something, usual notion is to take your data to that function and get everything done by the function on that data and get the result. But in data locality, when you have a lot of data, it's not really advised to take your data, from here to where the function is and apply everything. So what you do is you bring your function to where your data is, because that's cheaper now than transporting so much of data from where it is. So as you can see in the diagram, rather than traditionally moving your data from one point to every process that you want to perform it, bring your processes to where your data is. Now, you should be aware that this is a very smart thing to do, but not when you have little data, because bringing the process from where it is to where the data is not the easiest of things. It requires some setting up and some more resources than normally required. But when you have a large amount of data, it saves a lot as compared to bringing the big data from where it is to where the processing is. So you should be aware of that trade-off and and you should know that this works only when you have a lot of data. So I would always advise you to take any algorithm and think how it can be applied in a distributed environment. We encounter so many different algorithms every day. And if you're able to think what would be the map step for this algorithm and what would be the reduce step in this algorithm, how can I parallelize this to save a lot of time, then that is a great thought exercise to do. And I would definitely urge every one of you to do it. So I guess we have enough time now for taking one example called the k-means clustering and trying to dissect it and see how it works in a big data environment. So for those of you who don't know what clustering is, it is just grouping points such that similar points are together and points which are not similar to each other are as much away from each other as possible. So k-means clustering is a very simple algorithm in which we want to group our data into k clusters. So let's say I want to group into 2 clusters. My k is 2. So what I do is first I start off with having defining some 2 random centers for my 2 clusters. And then for every point that I have in my data, I see the distance between my point and every center that's defined. In this case, we have 2 centers because k is 2. And then I see which center is my point closest to. So let's say our cluster centers were A and B. And my point was closest to A than B. Then I will label this point as A, and then I'll take my next point and I'll find which is it closer to. So if I find it's closer to B, I will call it B, and I will keep doing this exercise for all the points that are there. So at the end of the step, what I have is a list of points which are classified as either A or B. Then what I do is for all the points that were classified as A, I find the centroid of all these points which have the label A. And I do the same exercise for the points which have the label B. So now I have 2 centroids, right? I'm going to call these 2 as A dash and B dash. And I'm going to use A dash and B dash just like I used A and B before. So I'm going to take every point and measure its distance between itself and A dash and between itself and B dash. And I'm going to find which is it closer to. And then I'm going to give it the label A dash or B dash. And at the end of this, what am I going to get? I'm going to get a set of points classified as either A dash and another set of points classified as B dash. So I'm going to continue doing this till I get a constant cluster, like the centroid value doesn't change and all the points are going to belong to the same cluster even after 2 continuous iterations. So that's great. That's k-means clustering. And I think I have a small example here where you have 7 points. And let's say their coordinates are 1, 1, 1.5, 2, and 3, 4, and so on. So let's say we took 1, 1, and 5, 7 as our initial centers. So we can just do the same routine of finding which point is closer to which center and give it that label and keep continuing the iteration until we finally suppose get 1, 2 belong to this cluster and 3, 4, 5, 6, and 7 belong to that cluster. Great. So this is a basic idea of how k-means works and what k-means algorithm is. But that is not what today's session is about. Today's session is about giving food for thought and thinking how do I convert my normal machine learning algorithms to be able to work for a big data context, right? So let's take a moment to think about in this algorithm, what would happen in the map phase and what would happen in the reduce phase. Because if you understand this, then most of your work is done. Because input splits and combining the output are very straightforward steps. So I'm going to give this word count example again so that you just look at it and you try to think what happens in the map step for k-means in a similar way. and what would happen in the reduce steps similarly for k-means. So let's try to start from the input step. Here for k-means, our input is going to be a set of points. And after input splits, you're going to have those set of points sharded as a few points in each of the blocks. So in word count, for mapping, we did just counting the count of each word in that split, and we wrote it. So think what would be the map function for k-means algorithm. So here's what is going to happen. You initially define two cluster centers, the random cluster centers, let's say A and B. What you do is for each of the points in your single unit, so in my first unit I have P1, P2, P3, I see which cluster center is it closer to, which means for every point in my unit, I find the distance between that point in A and that point in B, and I find which is it closer to, and I give it that name. So I found P1 was closer to A, and I found P2 was closer to A, and I found P3 was closer to B. So I do this of finding the distance between the point and every cluster center for all the points in my unit. So all these can be done in parallel. And that is what is going to save a lot of time. So after mapping, what we have is in each set, what cluster center is each point closer to. And then we will have to shuffle and combine all this together, right? So how we combine is we combine all the points which were labeled as A together and all the points which are labeled as B together. So now we have all the points which were labeled A and all the points which were labeled B. And then we do the reduce step. So what would the reduce step be? In the reduce step, we're going to calculate the centroid of all these points that were labeled A and all these points that were labeled B. And again, this can happen in parallel. So you get a new centroid A and new centroid B after parallelly calculating the centroid of the set of points that were previously labeled as A and B. And once you have a new centroid A and new centroid B, I think you know what to do. You can give it back to each of the individual input splits, and in the map phase, find the same distance between each point and each of the cluster centers, except now we have a new cluster center, which was the newly calculated centroid. So we can keep doing this iteratively until we get our closing criteria of a very small error. So to summarize, in the mapping phase, we are finding the nearest center for every point coordinate. And in the reduce function, we are going to compute the new cluster centers. So I just took this k-means example because it's very intuitive and easy to understand as to what happens in the map function and what happens in the reduce function. And I would really urge all of you to take every algorithm that you have and try to think if it can be applied in parallel in the first place. And if yes, what would the map function be and what would the reduce function be? Because you need to understand what is the difference when you use, say, Spark's ML library as opposed to some other normal ML library. And here's an interesting thing that you can do. So have a huge data set and apply k-means clustering, which from scikit-learn, and on some part of the data and find how much time it's taking, and do the same by increasing the data that you give to the model. Try doing the same thing by using Spark's ML library's k-means algorithm. And you will notice that Spark, when it's doing k-means on the data, if you plot a function of, say, the amount of data and the time taken, it'll be fairly a straight line, a horizontal line when it's with Spark. But when it's the regular algorithm, you'll notice a very increasing trend of time as compared to the amount of data that you give. So that I think you should definitely try and see for yourself how beneficial these frameworks are, especially in the context of big data, because yes, we do know that it's important to know all these frameworks and implement those functions, but I really feel it's important to understand how each of these algorithms work and how they work in different environments, because that's when we will be able to able to make intelligent decisions and know what to use where when we come up with a problem. So I really hope I was able to tell you about understanding how machine learning is to be applied in a big data context. Because as we all know, big data is really ramping up. There's a lot of use with all the amounts of data everywhere. So thank you so much for this opportunity, and I'll be very happy to take questions.
Hey, Shivani, thank you so much. So we'll take questions first, and then we'll talk more about. So Naveen has a question like, does word tokenizer work with a similar concept of map reduce?
Yeah, by word tokenizer, I'm not sure what you mean, but I'm assuming you mean in the NLP context of giving tokens to words. Yes, definitely. As I said, you can take any algorithm and put it through this funnel of map reduce, and you should be able to give what would be the map phase and what would be the reduce phase, and any algorithm can be converted into a map reduce format. I should also give you a little bit of disclaimer here that not every algorithm will work perfectly with MapReduce. For example, there's this another algorithm in machine learning called K nearest neighbors, where for every step you need to know about every other point which is there. So if you're going to split all your points into different computers, which you don't have access to when you're doing the map step, then you're going to involve a little amount of approximation here. So the answer that you get is not going to be as accurate as if you didn't use MapReduce. So yes, you can use word tokenizer and any other algorithm in NLP as well with MapReduce, but you need to be cognizant that there might be some approximations that are happening.
I hope Naveen that helps your that answers your questions.
Absolutely. I'm sure you can take this very example and try coding yourself in C++, following
Yes.
that pseudocode.
But yeah, but when you say map reduce, people initially like think, okay, because it was initially written in Java, so they
Yes,
think,
yes.
okay. But it can be re-implemented for sure.
Yes, definitely.
Okay. We have one more question here. How did you start out in machine learning and big data? And how was your journey to Microsoft Store?
Okay. Um, so how I started off in machine learning and big data is, so I think when I completed my 12th, it was pretty early for my time. But when I was in my early first year itself, I used to see articles in the newspaper about that time. There was this talk about data science is the sexiest job of the century and things like that. And I was really attracted because math was my favorite subject and I was doing CS. And this really looked like a marriage of math and CS. So I got really interested. And in my first year itself, there was a club in my college called Data Byte. And I joined it. And very early on, I was able to do machine learning projects there. And so based on those projects, and I think a competitive coding contest, I was selected to a hackathon in Microsoft. It's called Codes. It's a program for female engineers in their sophomore year itself. I visited Microsoft, and based on that hackathon, they gave a few of us an opportunity to intern after our second year.
So Jishan, that's how she started in that. So the questions we have. So I guess that's all we have from audience, but we got you some questions. So
All right.
first of all, yeah. So the talk was really interesting. Like I love like how you explain entire the map reduce process, how you can use them to like step by step using filters and then like making those items out of the filters. It was pretty amazing. Like I used to like this was my second like I would say a deep lecture kind of thing. When I was in college, I used to take this kind of lectures from professors, but this was really insightful. Like I could really imagine, like some teachers teaching me against the entire concept. So it was really amazing. So if you have seen our tradition, like even on yesterday's conference day also, we used to ask 5 questions, like in terms of rapid fire questions. So here
Yes.
we start with you. So we
Okay.
have heard that you also do karate. So what inspired you to do that?
Oh yes. So I learned karate, I guess, when I was in from my fifth standard. So I don't know. It's just a tradition in my house to enroll in everything that we are interested in, and karate especially. So there are two girls in my house, me and my eldest sister, and my mom really thought self defense was particularly important for girls, and so she just enrolled us in this karate class across the street, and I enjoyed it so much that I went on to get a black belt in it.
You got a black belt in it. Wow, that's
Yeah.
nice. Okay, so we have a next question. So, like 3 words, can you explain your experience uh, as a being a WTM scholar?
3 words. Empowering.
Okay,
I'm not sure if this is a single word, but giving back. And third would be community. So through this WTM Scholars Program and WTM itself, I got a great community, and they also give us funds to give back to the society, and and even being called a WTM scholar gives you that credibility with which I strive to do activities empowering women back in my college and every community I'm a part of also. So it's been a wonderful journey as a WTM scholar.
that's great to hear. Okay, so next question we have, like we'll have 2 more questions. One from the audience. We also got one question like, any resources to getting started with, any course suggestion to start it with give big data.
There is a course, I'm not sure by which university, on Coursera called Machine Learning for Big Data. And that's pretty interesting. But I think as developers, but just used to, Googling and reading so many blogs, and just get started on a project. And as you work, you will get a lot of doubts, and just Google them and get your hands dirty. I think that's the best way.
Okay. So, any tips for students like who are aiming to get into a companies like Microsoft, Google, or Big Fives?
Okay. To be very honest, this might not be a very popular opinion, but I think your aim shouldn't be to get into a big company, because I've had my experience interning at Microsoft. I've also interned at a startup called Rubrik. I've also interned in a couple of machine learning startups in IIT and Research Park, and all of them are totally different kinds of experiences. And I would definitely say it's not the best to have your goal is working for a large company, but I agree, those are really amazing companies. And if you are aiming to work there, then I would suggest to have a lot of projects, because when you do projects and you have them on your resume, it just shows on how credible you are, because you've shown that you can do a project, because that's what you're going to do in when you're going to start work there.
Yeah.
And most important, of course, is to clear their interviews and their preliminary screening. For that, competitive coding is I can't tell the importance of it. It's so important. You have to keep practicing your algorithms and data structures, and be very thorough with it.
So I hope like people who had this question, this helps a lot. So last question. So is there any favorite book of yours that you read? Like,
Book. So I actually started reading only very late, like a couple of years back.
okay,
I was never a lot of and it's non-fiction which I read. So I read this book called Deep Work, which is an amazing book, and it gives you a lot of insight on how to be more productive and all of that. And
okay,
I'm reading a book called Scale right now, which is by Geoffrey West. It's so amazing as to how it relates, the scale of organisms to how companies scale, and how the population in cities and all scale. So it's just, it has amazing analogies, and it's a great book to read. I definitely recommend everybody to read Scale by Geoffrey West.
okay. So Shivani, thanks a lot. Like I enjoyed your session thoroughly. It was really great.
Thank you,
So I
Abhishek.
hope to see you soon. Thanks a lot. Hope you had a like good time.
Definitely. Thank you so much. Thank you for giving me this opportunity.
Thank you.
So hello guys, I am back. So now this is the time to have some fun since this is a virtual conference and I really didn't want you all to feel overwhelmed with sessions. So I brainstormed some ideas to do something different. Oops, sorry. I mean me and my team brainstormed. I know they're watching me, so they're gonna kill me. So anyways, let's play the quiz. Okay, so this is the icebreaker. So I'll be showing you some tools and some of the Google products where you have to guess the color. So you don't have to guess the whole product color, but there will be very specific part. So let's get started. So here is your first question. Guess the colors. So I hope you all know what is this. And so if I want to give you a clue, this is the Google Assistant. So now you have to guess the color of the round where you can see the question mark. So you guys have a 20-second, then I'll be showing you the answers. 10, 9. I hope everyone is able to answer this because we have something for you. Every questions you answer. So all the winners will be getting something. Okay, so I am moving towards answer. I hope everyone has already answered it. Okay, so I'll give you 5 more seconds. So the answer is red. Like I said, this was the Google Assistant and you had to only answer the part like one round where you can see the question mark. So no worries if you haven't answered this question because we have others as well. So let's move to the second question. Now you all know what is this and you have to only answer the one specific part. I hope you all, I think this will be very easy to answer because we had so many, we all got so many goodies after completing this Google Cloud challenge. Okay, so I am going to show you the answer and I hope half of the people or maybe everyone would have known this answer. So it's a green and it's a Google Cloud. Let's move to the next question. So it's a Figma. Here you have to answer the color of the round where you can see the question mark. So I'm repeating it again so you don't get confused. I hope I'm a good help. Fast, fast, fast. Okay, so the color was blue. I hope everyone would have got this answer as well. Let's move to the next one. Okay, so if you follow the April Fool's prank from Google, you will be able to answer this question. And I hope everyone should answer this one. So this was the prank from April Fool prank from Google. You guys have a very limited time. Please make it fast so we can move to the another questions. I can see some of the answers. So let me show you the answer. It's a red. So I think you all got confused between blue and red. So that's the reason I said you all to all see the question mark and then answer. So that was a red and next one was blue. Let's move to the another question. Here you have to guess this color. I hope all of you will be able to do this. Guys, I hope you all know that speed really matters. So you have a very limited time. I'm going to show the answers in 5 seconds. So it's a PyTorch and the color is orange. So like I said, so not every the picture or whatever icon you see is gonna be from the Google product. It can be any tool. It can be Google product or anything. So you have to consider that thing and then you have to guess. So I think if you're able to find what is this sign is, then you'll be able to answer the questions. Let's move to the another one. So here you have to guess the again one triangle where you can see the question mark. Guys, make it fast. Let's go to the answers. Okay, so it's a Spark AR and the answer is dark blue or indigo. So if you have answered anything, you will be good, the right answer. Let's move to the another one. So what is the color of this one specific part? I don't think so you have to guess the color of the whole product, but you have to guess the color of the area where you can see the question mark. So for your information, this is not the Google product. I hope everyone has already answered. So let's see the answers. Okay, so it's a Adobe Experience Manager and the color is brown. I hope you all are fighting very closely to be the winners. So let's move to the next question. And then after that, I'll be wrapping up. So this is the final question, guys. Make it fast. You have a 5-second left. So I don't have a specific time, but I'm giving you enough time so you can answer. Okay, so let's see the answers. 5, 4, 3, 2, 1. Okay, so this was the Google Data Studio and the color is blue. I hope you all had fun. So that was main aim from this whole quiz session, to engage with you all, and so you guys you're not supposed to feel overwhelmed with continuously sessions. So after this amazing quiz game, we have a next session by Akshay. So our next speaker is a ML and big data researcher. He works at Symantec as a software developer engineer. He has also been awarded as the most influential young data scientist of the year 2019. So I would like to welcome Akshay. I hope he is already here. So the stage is all yours, Akshay.
Hey everyone, I hope you guys can hear me. Abhijit, if you can add my screen to the stream as well, that will be helpful. Yeah, okay, makes sense. I'll quickly start sharing it. Presenting it. Yeah, all right. So before we start, just want to give you a brief about the session as well as about myself. So this session is going to be about entering human features using deep networks. So this is a combination of both image processing, computer vision, as well as some in concepts of machine learning. At the same time, we'll also look at some of the shortcuts to use when you're working with machine learning. And this can work for your specific use case. So feel free to, if you have any questions, feel free to, drop in the live comments, and I can pick them up one by one, either after the session or during the session as well. So without further ado, I'll just start. Okay. So, and you can find me on akshaval.com. I'm also on Twitter, Akshabharat3. So if you have any questions, you can feel free to message me or tag me in any of the posts, and I'd be more than happy to answer your queries. A big thanks to the GDG Chennai team, because organizing this event at this time at the same at this time, as well as making sure that everybody's engaged, is definitely tough. So a big thanks to them, especially Abhishek and Jui, for taking care of all the logistics during this time. And I hope everybody who is listening to who's part of this conference has fun, and also at the same time gets to learn something new, and of course is safe and at home as well. So a bit about myself. My name is Akshay Bahadur. I'm an Intel software innovator. I'm also a Google developer expert in machine learning. Apart from that, I work at different companies. I have been part of a company called Symantec, which is in cybersecurity, where I worked in big data and analytics. So it's pretty interesting. Uh, so before we start, an important link that I have is this one. So if you want to have a look at the repository that I'll be using, go to bit.ly/devsangamam hyphen 20. So if you click on the link, you will be directly transported to my GitHub repository, which contains all the details of the slides, the codes, as well as other important links that you would want to follow up. So, after the session, or maybe even during the session, you can definitely have a look at this link. So it's bit.ly/devsangamam hyphen 20. All right. So let's start with some basic understanding. And by basic understanding, I mean that there are some concepts that we learned back in our college or back in our school, which is very important, and we don't really understand the importance of it until we use it in a machine learning problem, or until we use it in any problem going forward. So we'll start with a very basic question, or a very basic, very basic data set. So the data set is called as MNIST. Everybody must have heard of it who is working in machine learning, or just started with machine learning. It's basically digit recognition. So what I'm trying to do here is, before we go any further, so this presentation will contain some videos of the demonstrations. It will contain some code snippets. So it will not contain the entire code snippet. For the entire code snippet, you have to follow the link that I just mentioned. You'll find the Collab notebook in that link, and you can then have a look at the entire Collab link, which will contain a lot of details. So just for the sake of this presentation, I've kept it short. So this function, what it does is that it shows the data. So we'll have a look at the data. So this is how our data looks like. So we'll have the image of the digit 3, and it has a label which is of digit 3. Okay, so so I try to do something. I'll try to see the shape of my image. So it's a 28 by 28 sized image, which means that it has 28 pixels in height and 28 pixels in width, and it is only black and white. So you don't have a color channel in between. And if I try to print the the numbers, or print the pixels, you will find that these pixels they range from 0 to 255. And this is because the pixel intensity varies from 0 to 255. And that's what you see when you actually print out the pixels of each image. Now, what we see in this image is that our data is scattered, or the data is skewed. That is, in most of the cases, you see that the image has only the digit 0, which means that it does not have any color, or does not have any intensity. And you also see intensity of 255. But this is a very highly skewed data set. And this is not very problematic, but at the same time, this makes our model to learn very slowly. Okay, so now what comes into picture is a very simple technique called as normalization. And normalization is something that we guys have studied back in our schools when we started out with statistics. So what is normalization? Normalization is basically you make sure that the spread of the data is within a certain range. Okay. So what I do is that I divide the entire data set by 255. Okay. Which means that I have divided the entire data set by the maximum intensity. And when I print out the result, I get my data set which lies between 0 to +1. Okay, so earlier we had data sets ranging from 0 to 255. Now it is ranging from 0 to 1. Okay, and this is pretty interesting because this concept came from statistics, and it actually helps us a lot when we're training models. So let's look at that. So I do some analysis, that is how many numbers of examples are there. And then of course, how many are my training set and how many are my test set. And then I've defined a simple model. It is a simple fully connected layer without any CNN networks in between. Now, this is just some basic, a cluster. I mean, this is some model outline that we are looking at. And now, if you look at it, if I train the normal data set or the unnormalized data set that I had, the value ranged from 0 to 55, I see that the loss is 0.26 and the accuracy is, the loss is 11 and the accuracy is 26%. And this is after 2 iterations. And if I do the same thing with normalized data set, what I find is that the accuracy has increased to 93% and my loss has actually gone down to 2.24. So with a simple technique that we studied in mathematics or that we studied in statistics, we have actually increased our accuracy by 4 times. And this is something which does not really concern us at this point, but all I'm trying to say is that all the concepts that we have studied in the past, whether it's mathematics or whether it is electronics, each of them plays a very important role when we are working with such a diverse field like machine learning, which has a lot of integrations with each technology. So with a simple technique in mathematics that we studied back in class 10th or 12th, maybe, we have actually increased our accuracy by 4 times. Now we'll come to the main topic that we wanted to discuss. We will be using computer vision or OpenCV. Before that, this is just a simple outline of the accuracy and the loss, which you can see, and you can find out that the accuracy on the normalized data set is very high. So before we start, we are now coming to a main concept or main aspect of our presentations, is that you want to feed the content through webcam. So I will display a couple of different techniques of how exactly can you do that. So now feeding content means that I will show something to the webcam. I hope that my webcam is able to recognize it. And it has different, a lot of complications, but I will try to abstract that. I will only tell you the important aspects, and then of course you're free to explore it as much as you want. And we have something called as OpenCV. It's a Python library that helps us, do some calculations on using on image processing. Okay. All right. So we have something called as cap.read, which means that I just want to read from my webcam. Okay. And then I've written a function called as get image contour threshold. We'll discuss this in detail, but let's just imagine that it gives us some contours, and contours are our area of interest. Okay, so let's say if I've showed an image of myself, maybe my face is a contour because that's an area of interest to me. And what I do is that if I find a contour, that is the length of the contours are greater than 0, and the area of the contour is greater than some threshold value, or maybe it is a maximum of all the contours, then I do something. Basically, I get the image, I resize it, and at the end, I do a prediction on the image. Okay, so this is the basic concept, or this is a basic ideology that we follow, at least in this session, is that we will get some contours, we will get the maximum contour. Basically, we want to make sure that because we can have some we can have some background noise. So we will eliminate that. We'll only be looking at the contours which are the highest value. Okay, and then after getting that, we will just call a predict method on that image that you have seen. Okay. So basically, the prerequisite for this is that you should have a trained model. Okay, so we'll not discuss about that, but let's just assume that we have a trained model. The only thing is that you want to integrate it with computer vision or OpenCV so that we can do analysis, through webcam at runtime. Now, the get image contour threshold, this function, what it does is that first it converts the image to a grayscale image because working with color images is slightly complicated at this point because we haven't discussed a lot of things. So we will just convert it to grayscale. That is, it has only one channel now, black and white. And then I'm blurring it. Blurring basically means that I'm reducing the edges from the from the image. Then the important function is this one. Okay, so because of OpenCV, it comes with a lot of out of the box functionalities. So we don't have to worry about the details of it at this point. We can just understand that what it does is that it finds areas of interest depending on certain threshold values that we have set in the past, and it gives us some contours, and we are returning these contours or these areas of interest to our main function, and then we are performing some calculations on that. Okay, so this is the basic outline that we have. And using this functionality, I have developed an application which is called as Digit Recognizer. So if you look at this video, all I'm trying to do is that I'm showing it the image of a digit, okay? And my OpenCV application gets the contours from the image and then trying to make predictions on that. So right now you can see that it gets the image of the digit 7 and it makes the prediction 7, and all of this happens in runtime. Okay, so this is the basic concept of one of the most simplest applications that you could develop using machine learning and computer vision, showing something to the camera and making sure that your model predicts that particular image. Now the next thing that I wanted to discuss is writing through webcam. So right now we are showing something, we are showing an image. Now if I want to draw something using my fingers or using my fingers as an input modality, how can I do that? So once again we will go to something very basic. Okay, so once again cap.read means that we are reading our image. Okay, then we have a very important function which is called as in range function. Okay, so what it does is that my image in the image I have a region of interest. Region of interest basically means that that region is important to me and I would want to only analyze that region. Okay, and in range what it does is that it gets me the range of the colors that I'm interested in. Okay, so within a region of interest, let's say if I have a green color, so this lower green and the upper green are the boundaries of the color green in BGR format. So every color, every color is made up of BGR, that is blue, green, and red. They have certain pixel values, and that amounts to the color green for the computers. So what I've done is that given a region of interest, I want to make sure that I get only the color green, and once I get that, I simply do a bitwise AND. Okay, so bitwise AND is a concept that we have studied in mathematics or maybe in electronics as well. So you'll do a simple AND operation. So if I do an AND of an image and a part of the image that contains only green color, so after the AND function, I will get only the green color from the entire image or from the entire region of interest. Okay, and this is a very simple concept which I have explored or exploited, as I can say. And once that happens, I again call the find contours function, which basically gives me the contours with respect to a color that I'm looking for. And then using this contours, I'm trying to do something. And this is slightly complicated, I'll say, but you don't need to worry about it. It's fairly straightforward. So if I find a contour, if length of the contour is greater than 1 or equal to 1, which means that I have found a contour, okay, what I try to do is that I add this add this point, or because everything will be a point, if you're getting a contour, it will have a central point. Okay, so I'll get the central point and I will store it in a queue. Okay, so let's say if I try to draw something, if I try to draw something with my hand, it's going to get my hand and it's going to try to trace out the path of my hand, and it's going to use that what can you say, coordinate, and store it in a queue. Okay, and once it is stored, what I do is that once I remove that, remove my hand from the image, that means that I have drawn my image, or I have drawn whatever I wanted to draw. And once that happens, I simply call a find contours function, and I send it for predictions. Okay, so it's slightly more complicated at this point, but the whole idea is to trace out the path of the object that I want to, that I'm interested in. And then once I have drawn something, just keep on adding the points or the central points, tracing out the path to queue. And once I remove my hand, or once I remove my object, it's going to send it to predictions. Okay, and this is a simple example of that. So this is called as digi encoder. So right now you can see that I have a small blue color object in my hand, and I'm tracing out the path of that blue colored object. And that essentially I'm drawing a digit, and then I am asking my model. So I have three models. I'm asking my model to draw the same digits from their own memory. Okay, so I've created a model, an encoder function, which basically encodes all the digits to a lower modality. And then once I draw the image, they try to predict, or they try to draw that same image, or draw that same digit from their own memory. Okay, and this can be easily done if I have this functionality that I just showed you. So now we have seen something for drawing. Now we will discuss about hand gestures. Okay, so let's say if I want to get the hand gestures from the image. So let's say right now if I have something like this, so I want to just see my data. Okay, so this is me pointing my finger upwards, and then you can also have a victory sign, at the hand gestures. But now what you see is that this is a black and white image. So naturally it means that we have some filters in place which gets the entire image. It gets the hands from the entire image, and at the same time it filters out the black and white aspect. So only you will get only a black and white image of your gestures. And this performs well because you are not worried about the black and white, or maybe you're not worried about the color aspects of the image. At the same time, it's very fast, so you can do your predictions or calculations at runtime without worrying about the resources. So this is a model that we'll be using for this. So this is a simple CNN model. Okay, we'll not worry about the model at this point. And this is how it looks like. So I have trained the model, I had the gestures in place, and you can see that it is almost 99% accurate, which does not make sense, but for the sake of argument, we'll say that it's a good model. Now comes the interesting part. Okay, so now we have seen the power of in-range functions in CV2, which means that I specifically get a specific color from the entire image. And similarly, I try to do something of similar sorts in this as well. So the two values that you see, 250, 60, and 25, 150, 255, are actually colors or boundaries of the skin color. Okay, so these are static in nature right now. So mostly everybody will have the skin color ranging from this lower value to the upper value. Okay, so when this happens, again, similar concept, a bitwise AND, which means that I will only get my hand skin color, not just hand gestures, skin color from the entire image. Now the important aspect is I have to extract only my hand gestures. Okay. So for that, we have certain other filters in between, which are slightly more complicated. We will not discuss that at this point. But you can understand that these are some filters which I have added so that I can extract my hand gestures. And then at the end, I'm doing a simple find contours, which we have been doing for the last 3 examples, and it's pretty effective. Okay. So once we have the contours, we get the maximum contour. and then at the same time we just do a predict model or keras, which is a function which basically predicts given my image that I've just extracted from my contours, and making predictions. So we'll see. So this is an emojinator project that I did. It's pretty interesting. So right now, what you see is one of the work that I did a couple of years back. So yeah, so right now you can see that I'm extracting my hand gestures statically at this point, and at the same time I am overlaying an emoji corresponding to that gestures, corresponding to that gesture. Okay. Uh, so yeah, so right now, if I'm pointing the thumbs up, giving a thumbs up to the webcam, it's doing the same thing. Now this is emoji for a dog, and then similarly you will have other emojis as well. So I'm making predictions at runtime. The important thing to notice here is that it's pretty fast, so you don't have to worry about a lot of resource crunching because you're working with a lot of filtering in the backend. You're only working with black and white images, so it makes a lot of sense. Okay. At the same time, you can definitely have a look at the entire code. It's on my GitHub, but let's just move ahead. So this is a V2 version, which we will not discuss at this point, but it has something to do with a much more advanced algorithm for object detection. So right now, instead of having some filters in place, I have an object detection API which detects my hand gestures from the entire image. Like uh, using my color image. So even if I had some background noise, this will still work, but it is very heavy on resources. Okay, then similarly, if you have done this, you can do something fun with the application. So this is what I did based on the gestures that we were seeing. I developed a simple rock, paper, scissors application or a game that you might have actually played as a kid. So yeah, so this is me playing rock, paper, scissors with the CPU, and you can of course get the result in real time. So this is pretty fast. It's getting my hand gestures. It's trying to see whatever I'm corresponding to, and then based on that, CPU picks up one of the emojis randomly, and then whether it's a draw or a win or a loss, it tells me at runtime. This is just for fun. So till now we have seen, how we are drawing using our hand gestures, or whether you're drawing using your fingers. Now let's look at some eye aspect ratios. So one of the important aspects of machine learning is actually using a pre-trained model for your own advantage. Okay, because you cannot expect yourself to try and train everything from scratch, because after some point, because it takes resources, you don't want to waste resources. If somebody has already done that, you can just pick up their implementation. Of course, you can add them in the references, but pick up their implementation, try to better them at some point, and just give it back to the community. So we'll be looking at some of the eye, eye as an eye as something that you could feed to our system. So essentially, this will look at the different features of eye, basically when the eye is closing, when it's opening, and then depending on that, we have different applications. So we have something called as DLib, which is a library in computer vision. It is a pre-trained model for detecting different facial features. Okay. So if you see, we have face utils and getting the landmarks of my left eye and the right eye, which is a pre-trained model. We have a eye aspect ratio function, which we will not discuss in detail, but just try to understand that it gives me the ratio, or it tells me whether my eye is closed or not. Okay, let's keep it simple. So what we do is, of course, we do cap.read, which means that I'm going to read from my from the webcam. Okay. And I'm trying to detect some faces. I just want to detect some faces. Okay. And then within the face, what I'm going to do is I'm going to get the left eye and the right eye. And then once I have that information, or once I have those coordinates, I calculate the eye aspect ratio. Okay. And once I have that, I draw contours. So right now we are finding contours. Now we can even draw some contours. Okay. Let's look at how we are drawing contours. Okay, so and if the eye aspect ratio is less than a threshold value, and if it is less than a threshold value for some amount of time, we can simply display an alert stating that the person is sleeping or he is drowsy. Okay, let's look at that in example. Okay, so yeah, so right now you can see that my eyes has some green outline, and that is done using draw contours functionality. So we were finding contours, now we can even draw some contours. And if I'm closing my eyes, my eye aspect ratio drops to a certain value, which is a threshold value. And you can see that after a certain amount of time, there is a alert that is being generated. You can use similar technique to have a Morse code decoder as well. So somebody, people who are less fortunate than us, who cannot speak or do not have any motor functionalities, can use Morse code to communicate. So right now Morse code is in dots and dashes. So a small eye blink means a dot, a longer eye blink means that I'm dashing, and then you have these dots and dashes corresponding to different alphabets. So similarly, I'm trying to print hello, and you can see that the Morse code for the hello is on the screen as well. So I'm trying to make sure that I write it correctly, so that it's, of course, it's a bit hard process, but at the same time it works for people who are less fortunate than us. So yeah, it's open for interpretation. You can of course have a look at that, even improve it if you want to. So yeah, now we'll come to facial recognition. So we have discussed hand gestures, fingers, feeding through webcam. We also looked at some eye features. Now we look at some facial features or facial recognition in general. Okay, so we have a technique or a research paper called as face nets, which is beyond the scope of this presentation at this point, but it's good to have a good knowledge of it. So let's. So before we start, we have a function for getting the encodings, which is basically you feed your face to the image or to the function. It gives you a very unique number. Okay, and that number is not an integer. It's a float number, which is different, which is very different for different people. Okay, so let's say if my face has a number of 1.2 or 1.33334, Abhishek will have somewhere between 2.7, which means that we both of the faces are different. So this image to encoding function does that for us. Okay, and how it does that is beyond the scope at this point. But if you want to have a look at that, or if you want to understand, read the research paper called as face nets, which is one of the initial research papers for facial recognition. Of course, if you want to have a discussion with me, feel free to do that as well. But for the sake of argument, let's just assume that it gives you a very unique encoding. Okay, and then you can add all the photos of the valid people in the database. So that's what I'm going to do. Okay, and this is an important functionality. So once I have the image, I try to get the difference between the encoding from the face and the encoding that is present in databases. So we can have, let's say, 10 faces. So it's going to compare the distance between the face on the webcam to all the faces that are in the database, just to make sure that I get if a person is present in my database, so that I can say that this is actually an authenticated person, so he can access this. Okay, so if it is less than some distance, so if distance that we calculated is less than some minimum distance, it's going to get display the identity. So let's look at that in action. So right now in this video that you will see, it has my brother and myself. So his name is Apur. So you can see that I have two faces in my database. One is Apur, one is Akshay. So right now I'm feeding myself my face, and the distance is 0.0009, which means that this webcam, this image from webcam, is very close to an image from the database, which corresponds to Akshay. Okay. And one additional feature that I added is that if I'm not looking at the camera, or if my eyes are closed, then there will not be any predictions, which means that, let's say, if I'm not looking at the camera, then, which is inspired from iPhone's functionality. That is, if you will have a face unlock only when you look at the camera. So now we have seen hand gestures, we have seen fingers, we have seen faces, we have seen eyes. So if we add all of these functionalities, or if I take out some functionalities, I can actually solve a problem. So what I solved is called as Indian Sign Language Recognition, or ISL, ISLAR, or ISLAR, which means that I want to develop and standardize an Indian Sign Language recognition system. Okay. So what I did was I did not take the entire image into account because I knew that I could filter out only the relevant information. That's what I did. So this is how my data set looks like. So right now you can see that I have only extracted out my facial features and my hand gestures. Okay, so this is pretty interesting because you are not worried about about the entire image. You are only worried about the image that you're interested in, or the part of the image that you're interested in. Similarly, these are not all the gestures, but some of the gestures that I developed. And if you want to have a look at that in action, this is how it looks like. So right now you can see that I have a lot of background noise in my image, but still I'm only working on this part of the image, which means that I don't have to worry about a lot of background noise. I can still make predictions at runtime because I filtered out all these informations. Okay, so you can have a look at this implementation. It's not on my GitHub currently, but it is on my I have written a blog on that. So definitely feel free to reach out to me if you want to get more details on this. So right now we have seen a lot of things. We have seen hand gestures, fingers, facial features, eyes, other facial key points. Now we have something called as pose detection, which means that I want to detect the entire pose. And this is not one of my work that I've done, but the beauty about machine learning or the community is that people do a lot of things which they open source, and anybody or everybody could just go ahead and give that a try. So this is actually called as open pose by CMU or Carnegie Mellon University. So some researchers at CMU, they came up with this algorithm and then they open sourced it. So let's have a look at that. So right now you can see that they're working with facial features as well as they're working with different poses. So you can see that you can work with just the skeleton based system from the entire image. So let's say if you have a lot of if you want to, let's say, work on the entire skeletal system of a human being, you can simply use this open pose library by CMU, and you can do that. You can do your work quite easily. I try to do something similar. So this is same thing that we just saw called as Emojinator. I try to do this using OpenCV or sorry, not OpenCV. I try to do this using OpenPose. So right now you can see that it's not very clear at this point. Probably does not even make sense for me to integrate it with Emojinator at this point. But I just wanted to give it a try, and it performs really well. So if you're looking for something which works with the entire human skeletal system, you can definitely check out this particular implementation by CMU. Okay, so I think we have covered a lot of things. We have covered features, facial features, eye gestures, hand gestures, fingers, as well as now we have covered the entire skeletal system or human anatomy. So with that, I will like to say that I have concluded my my work. And if you have any questions, feel free to ask me. Right now, you can even go to my GitHub repository. You can ask questions there, or you can add me on LinkedIn as well. Feel free to give me any feedback if you have. If you feel that you want to, if you feel that I can improve it in some way, definitely feel free to do that. Go to akshayavadu.com. That's my website, and you can give me any feedback on my present work. At the same time, just want to thank you for everyone for attending the session. You can find the details again at this point, bit.ly/DEV Sangamam-20. You can find me at akshaybahadur.com, and at akshaybahadur3 is my Twitter ID. So feel free to ask me anything on Twitter as well. So that was it about myself and the presentation that I wanted to show you. If you have any questions, feel free to do that. I will be more than happy to answer any questions that you have. Okay, so I'm going to stop sharing now. Abhishek, I hope that's okay. Yeah.
Yeah, that's fine. Thank you so much for session. I guess we are open for questions. So you will be taking your questions. Then later on, Julie will be joining you. She got a lot of questions for you.
Oh, okay. Yeah, yeah, definitely. So do you want me to look at the live comments or will it come directly on the screen? Yeah, so definitely, Google Colab does have the issue with real feed webcam because when you're working with Google Colab, you're actually working on a VM. So let's say if you do something called as tab.read or open the webcam, it's not going to open your local webcam. It's going to open the webcam of the VM where you're running the Colab notebook. So what I do is I train my models on the web on Google Colab, and once I've trained the model, that's when I download the model and I then run it locally. Okay, and if you don't want to do that, you can read about TensorFlow.js, which helps you do everything through the browser itself. Okay, so right now there's no alternative for running your local webcam on Colab. You cannot do that. So you just make sure that you download the model and then run it locally for using the local webcam. So dot flatten, what it does is that let's say if I have a matrix of let's say 3 by 3 or x by x, and if I want to flatten it out to a single vector, not from a matrix to a vector, that's when you call a flatten function. So it's just going to roll the entire matrix into a single column or a vector. I hope that answers your question. Uh, mm, so yeah, Bhavani, it is not mandatory. So everything that you saw, that everything that I developed was only using CPUs. Of course, using GPUs definitely help, but I did not have that liberty at that point because at that time Collab was not very popular, and at the same time, uh, I was unaware of Collab. So because and hence you can see that all of these filtering that I did was just to make sure that I could fit the entire data set in memory and I can perform computations in my simple laptop or in my local machine. I hope that answers your question. Yeah, so since mostly everyone is doing similar projects, yeah, definitely makes sense. When I started with machine learning, this was back in 2017. People were trying to get into the field of machine learning, and this they will definitely be the case at every point because you have a lot of people that are interested in doing something. So the so the demand is high, the supply is also high. So if you want to make yourself unique, working on something which is original is very important. So if you want to have a look at my example, I developed the sign language system, which was not done like the way that I have done by other implementations. By that I mean nobody was actually filtering out the or doing pre-processing on the image. They were just giving the entire image to the model to train. But I wanted to do something different. I wanted to make it more lightweight. Hence, I went ahead with that. So having some intuition of what exactly you want to achieve at the end will really help. So being original is one thing. At the same time, being consistent is also very important. So yeah, and then of course finding the right fit between a project that you work on as well as if you have to deploy that in an actual system, how will you do that is also very important. So yeah, I hope that answers your question. Uh, so yeah, so when it comes to machine learning, there are different aspects. Okay, so ML engineering comes from basically, so you have different tiers. So you have a research scientist, which means that, or a researcher, which will make sure that it creates these algorithms. You will have an applied scientist which uses these new algorithms and applies that to an to a problem statement and finds if it works or not. Then you have ML engineers, which will be responsible for actually pushing these models into production. By production, I mean that they have to be really thorough with the whole pipelining. Then you have data engineers, which closely work with machine learning engineers to make sure that your system is scalable. And then of course you have other layers. So if you want to develop algorithms that at the top, that is if you are a scientist or if you are a researcher, then and at the same time, if you are a researcher, it gives you a lot of you should be very thorough with your mathematics. You should be thorough with your statistics. But once you start coming down, let's say if you go to machine learning engineer, you have to be thorough with your computer science slightly more than your mathematics. Of course, having knowledge is very important, but if you go down this hierarchy, your computer science skills will start increasing and your mathematical skills will start decreasing. I hope that answers your question. How do you explore these projects? Any tips? First of all, I think it's very important to understand why exactly are you exploring any project. So by exploring any project, it means that you should have a end goal or maybe a slight intuition of what you want to do. So let's say if I keep on jumping from doing one project to another, I will probably be good at that particular project, but I cannot apply that to solve a problem. Okay. So let's say if you're working with NLP, then if you switch to computer vision, then you switch back to NLP, then you switch to maybe RNNs, or so you keep switching. That means that you have knowledge of everything, but you have not specialized in something. Okay, so what I will suggest is that make sure that you have a bigger picture in mind, that this is what you want to do, and then keep exploring, because every field or every specific every specific subdomain of machine learning is very unique and very vast. So just make sure that you know what exactly you want to do. I hope that answers your question, Abhishek. How does one understand where to apply? Yeah, so this is actually a very interesting question. I haven't heard this question before. I keep on asking this question. But according to me, a good machine learning engineer knows where to apply machine learning, algorithms, but a great one knows where not to apply these machine learning algorithms. So let's say, to give an example, let's say if I have to have a machine learning algorithm where I want to predict the number of leaves that are falling from the tree. So let's say I have a lot of trees and I want to predict that within a given month, there will be, let's say, 1,000 leaves that fall. So I want to make a prediction algorithm. Let's say, because during the month of fall, or what you call in Hindi as patjhad, you will have a lot of falling trees. So I want to predict that. So we'll go ahead, you will collect the data. Basically, you will count the number of leaves that have fallen over an year, and then you will have enough data to make your model. But the important question to ask here is that, is it really necessary for a model to do all this? Maybe the problem is much simpler than that. Maybe it's not even required, or maybe the problem is not even a problem because we don't really care about if the leaves fall or not, because this is just a cycle that keeps on happening. So if you predict the number of leaves that have fallen from the tree, it is not going to help anyone. So I hope that answers your question. So the short answer is to just keep on practicing. Once you have that practice in place, things will become much easier. Where do you see ML development in the next 5 years being necessary in various? So there are definitely, I feel that every field has a lot of scope, but coming from India, if I have to talk about Indian system, which I've already covered in my last topic for GD Chennai, is that I definitely feel that if we do good work in the field of agriculture and healthcare using machine learning, it's going to be really helpful, because it is going to affect a lot of people. It's going to make people lives a lot better, and at the same time, it's going to affect a large number of people. So because agriculture, India, around 80% of Indians are directly or indirectly attached to agriculture. So if you make something revolutionary using machine learning in agriculture, 80% of Indians will be affected by you. So I think that these two these two fields are very important personally to me. What is your advice? I think the best advice is to keep being consistent. If you really like machine learning, just you have to make sure that you have the basics correct. At the same time, you should also have the basics of computer science, which I just saw in the last lecture. That basics of data structures, algorithms are very important, because at the end of the day, all these algorithms runs on a computer, and you want to make sure that your computer is optimized enough to run these algorithms. So you have to understand these basics at any given time. Okay. All right. So I think these are all the questions. Yeah. So if, of course, if you have any other questions, feel free to reach out to me. You can find me on my website on LinkedIn. Okay. Hi,
Okay.
Julie.
Thank you so much for this amazing and informative session. And being an ML enthusiastic, I really enjoyed it. So,
Thank you
like
so much.
Abhishek mentioned, I have few questions. So by
Sure.
now you must be knowing our tradition, or even if you don't know, it's okay. Let me tell you. So I'll now ask you 5 questions, and this is gonna be like
Okay.
a rapid fire round. Are
Rapid
you
fire.
ready?
All right. Yep. I
Okay.
hope so.
What what does research thinking is different from startup thinking?
Uh, Actually, don't know, because startup thing is mostly about getting the product ready and shipping it out to customers. Research thinking is basically you want to make sure that you develop something new, which can affect a lot of people. So I think that's the main difference.
Okay, thank you so much. And the next question is describe your GDE experience in 3 words.
It has been enlightening. It has been fun, and it has been really informative.
Wow, that sounds really interesting. Okay. So, like we all know, you have worked on so many ML projects, and definitely you might have seen some other ML projects as well. So, what is
Yeah.
your favorite ML project that you have seen recently?
So recently, I actually explored this project by Hyong, which is a TensorFlow JS, which is called as pose animator. So basically, it you have it, and it works on a webcam. So you don't have to actually install anything. It works on a webcam. It's using TensorFlow.js. So you just go to that website, and it has an avatar of you. So whatever you do using all the poses that you do, maybe your facial expressions, is going to copy that. It's going to copy your hand gestures, your every moment. So I found it pretty interesting.
Okay.
Yeah.
And the next question is how do you see data of users in terms of privacy when a product is using user data for ML?
I think that is definitely a concern, because right now data is becoming something that is very important for every company, and of course for users as well. So right now, if you look at, so what I do is basically, if I am if I'm installing an application, I try to read the data policy, that how exactly will they be using my data. At the same time, if algorithm runs on your system itself, so let's say uh, what Apple does is that all the machine learning is done on your mobile phone itself. So that means that the data is secured in your mobile phone. So make sure that if you are scared about something like this, feel free to make sure that you read all this information from the developers itself.
Thank you so much. And the last but not the least, have you ever been to Chennai?
Yes, I have actually. So I have been to Chennai. I stayed there for a week. I stayed in actually T Nagar, and this was way back in when I was a kid, and but I remember it very clearly. And we actually went to this great idli place called as Murugan Idli Shop,
Yeah.
which is very popular. And that was my first time, and I had a lot of fun because I thought that the food was really great. So yeah, so definitely I would like to visit Chennai again. Yeah.
So, which is your favorite place?
Uh, Visit in
Chennai.
Chennai.
Yeah.
So basically, when we came, we just went for shopping. So my mom is very sari enthusiast. So she went to Nalli.
Okay.
I actually liked the place because it was a pretty huge building for a sari shop. Then I went to a couple of malls. We had, I think, Sarvana Mall, if you remember. This
Yeah,
was way
sir.
back.
Yeah.
Yeah, so I went there as well. But definitely, the best place is of course the Murugan Idli shop because I had a lot of cheap
Amazing.
idlis. Yeah.
Nice. So thank you so much, Akshay, and it was pleasure introducing you and having you on
Thank
board.
you so much. Yep.
So thank you so much.
All right. Thank you so
Now
much.
over to
Take care.
you. Okay, yeah. Bye bye. Over to you, Abhishek.
Okay. So thank you all for joining us, and a great thanks to all the speakers. It was really amazing session. Like we had amazing three talks, I mean back to back, and a fun activity by Jui. Well done. So thank you for having all patience all the while, and we really appreciate like you attended this session over a weekend. Thanks again for joining us today. It has been such an insightful day. If you see, our social media tags are displayed on the slide. So do follow us, tweet, post, share about the event. And before I end, let me give you a little sneak peek about next week conference. What we're gonna do next week. I hope this is a 4-day conference. We are doing on a split of 2 weeks, so that people get a time over the weekends and they can join. So don't forget to share about this conference to your colleagues and friends as well. Okay, and we also have a Slack channel to have a discussion around it. So you can go to bit.ly/gdgchn-slack to join our Slack channel. You can ask questions there as well, and we would happy to help you. So a little sneak peek of what we're gonna do in the next week. So next week of DevSangamam, it's all about most of it is insights about into a mobile, web, cloud, and security. And our speakers will be like amazing, and we will have so much store in your next week. So don't worry about that. We have a variety of topics, and you will be knowing like very well-known speakers are also coming who are like pretty domain expert as well. So tune in at @GDG Chennai over at Twitter, and you can also join us over a meetup.com/GDG Chennai, and you can also join our Slack channel as I mentioned on bit.ly/GDG Slack, GDCHN-Slack. So for more updates and having conversation, be part of community, and like come and join us. We'll be happy to share all the knowledge. Have a great week. See you soon. See you next weekend. Bye bye.